Hello guys, it's Johnny time and welcome to another blockchain security tutorial. Today I'm super excited to start a new video series which is going through solving and making some kind of walkthrough the Damn Vulnerable DeFi challenge, which is one of the best CTF capture the flags to practice smart contract hacking, DeFi and blockchain security. Today we're gonna solve the first challenge, which is the unstoppable one. If you want to make sure to get updates and watch the next videos, make sure to subscribe and turn on the bell notification button. Now, all the Damn Vulnerable DeFi exercises are based on real-time attacks and real-life examples of DeFi hacks that happened in the past where millions of dollars were stolen from smart contracts and protocols. So it's your best way to train this kind of high demanded skills. Now, without further ado, I'm super excited, so let's get started. So here is the website of Damn Vulnerable DeFi. It currently contains 13 different challenges. They all the time add new challenges, so make sure to come back to the website if you completed them all, because sometimes they post new challenges. And basically, in order to start solving the challenges, you go to the GitHub repository, you clone the repo, okay? It's quite obvious, quite straightforward. Clone the repo and then yarn install to install all the dependencies, and then you can start solving the challenges. Now, you have two important folders. The first one is the contracts folder, which contains all the vulnerable smart contracts of the challenges. Quite straightforward. Some of the challenges will require you to implement your own smart contract that will attack the vulnerable smart contracts, so you're gonna build it over there. And then you have the tests folder, which contains all the JavaScript test files that will be used to set up the environment, write your exploitation, and then check and validate that your exploitation was successful. So it will be much easier when we're just gonna solve the first challenge. So let's jump into it. The first one is the unstoppable. There is a lending pool with 1 million DVT tokens in balance offering flash loans for free. If only there was a way to attack and stop the pool from offering flash loans. You start with 100 DVT tokens in balance. So we need to cause some kind of denial of service attack to a flash loan smart contract. So the first thing you're gonna do is go to the contracts folder, find the unstoppable folder, and then you have two contracts, unstoppable lender and receiver unstoppable.sol. Then you can go to the test, find the same folder, unstoppable, and then you can see the unstoppable.challenge.js, which is the test file to verify that the exploitation was successful. While going through the first smart contract, which is the unstoppable lender.sol, we can see that it's a simple Solidity 0.8 version, quite updated smart contract. It imports the interface for ERC20 tokens and the reentry OpenZeppelin smart contract. It implements the iReceiver interface, which probably will be used to call the receiver fallback function, or like kind of like callback function, to receive the flash loan. And then this is the smart contract. It has two main storage variables, the damn valuable token and the pool balance, which will be used to track the balance of the pool, so we can know how much we can provide flash loans for people. Then you have the constructor, which receives the token address and set it up. Quite obvious and straightforward. Then we have deposit token function, which is very important. It gets an amount. A user can deposit tokens to the smart contract. It makes sure the amount is greater than 0, and then it transfers the tokens from the user that wants to deposit to the smart contract and updates the pool balance by adding the amount that was deposited by the user. Now, this is the interesting and supposed to be vulnerable function, the flash loan function, that receives an unsigned integer of borrow amount. It's external and non-entrant. It first checks and requires that the borrow amount will be greater than 0, quite straightforward. Then it checks the balance of the smart contract. This smart contract by calling the ERC20 token balance of built-in function. That's how it checks the balance. And then it makes sure that the balance is higher or equal the amount that the user is willing to borrow. So it doesn't want to borrow amount that is higher than the balance that exists in the smart contract, obviously. Now there is another weird assertion and requirement between an equalization between pool balance and balance before, okay? The pool balance is the storage variable that tracks the pool balance every deposit, and the balance before is simply the variable that was declared 2 lines of code before, where we check the balance of the smart contract by calling the balance of ERC20 function. This is interesting, and now you need to approach the attacker mindset. Like, how do you make this function stop working? And it's probably gonna be by making one of these requirements fail, because that's how the function will revert and the transaction will be reverted, and no one will be able to borrow tokens, which is the goal of this challenge. So let's take a look at the first requirement, which checks that the borrow amount is greater than 0. This is something that is not in our control, and it's probably unbreakable. Then we have another requirement that checks that the balance before is higher, greater, or equal than the borrow amount, which is another thing that we cannot break for all the users. What we can break for all the users, which is the solution. So if you want, you can pause the video, try to solve it yourself, and then come back to this video to see the answer. What do you think will be the requirement that will be able to break this kind of functionality? And you're probably right, this is the kind of weird assertion, because here the smart contracts checks that the pool balance, which is the storage variable that is being updated every deposit, is equals the balance that is coming back from the ERC20 token balance of function. If we can break this kind of assertion, then no one will be able to borrow tokens, because this transaction will be reverted. How can we break it? Simply by sending tokens to the smart contract without going through the deposit tokens smart contract. Because if we just send the ERC20 token directly to the smart contract, the pool balance will not be updated, which means that balance before will be different than pool balance. So this assertion will be broken for anyone who is trying to call this function, which is quite simple. This is kind of a warm-up for the more challenging ones, so it's quite easy and fun. This receiver unstoppable function, smart contract, is not even relevant for our purpose, because we don't care about what's going on after the flash loan and how it's implemented, because we just want to break this kind of assertion. And how would you break this assertion?
Guys, I wanted to share with you something super exciting and new. I've created a complete practical smart contract hacking course accumulating 12 years of my cybersecurity and blockchain experience. Without exaggerating, this is your holy grail all-in-one course which will instantly help you kickstart your career in smart contract hacking and security, making you the most demanded professional with insanely high salaries. Get exposed to tons of knowledge by signing up in the description below. Simply by sending 1, 2, 3, however how many DVD tokens you want to the smart contract. Now we have 100 DVD tokens, so you can choose how many DVD tokens you want to send to the smart contract. We will go to we don't even need to write or implement our own smart contracts, simply by sending it through ethers and JavaScript. So this is the JavaScript, the test file for the Unstoppable Challenge. You can see all the setup. This is the setup. So you can see there is 1,000,000 tokens in pool. There is initial attacker token of 100 tokens. Basically just doing all the setup that they described over here. So I'm not going to go to every single line of code here, because it's just going to waste your time. We just want to go to this kind of exploitation section and write our exploits. So at the end, at the after, the expected behavior will exist, which is the receiver contract execute flash loan function will be reverted and failed. So how would we exploit it? Simply by this .token, the connect. We want to connect our attacker address, and we want to call the transfer function, and we're going to send 1 token. So we'll add it await because it's async function. Okay, so we are simply sending the token. This is the token, so I just took the object of the token, which represents the smart contract of the DVD token. I connect the attacker, my attacker address to it, so it will be like me interacting, the attacker interacting with the token smart contract, and then transferring. I need to specify who I want to transfer. So the ERC20 transfer function, we can just copy this kind of example over here and change here at the connect, and
we have attacker. I don't need the address, I think, and transfer to whom? This.pool.address. We want to transfer to the pool, and we want to transfer only one DVT token. This is supposed to be more than enough. And then you can simply test if your exploitation works by executing yarn unstoppable. Now it will deploy the contracts, run the setup, and check our exploit. And as you can see, the exploit was successful, and we were able to pass this test and the first challenge unstoppable. So I hope you had fun and you learned some smart contract and Solidity hacking. And make sure to subscribe so you can get notified when I post the other videos in this kind of series. Thank you very much. If you have any questions, ask them in the comments below, and I will see you in the next tutorials. Bye bye.